trade wind or the easterlies. Why are they named trade? Trade means business. So why are they called as trade, not anything else? Like the winds are named according to the direction from which they are originating, but they are known as trade means business wind. Actually, they are very calm wind. They flow at a particular latitude throughout the year in almost same direction with a constant speed. Okay. So in ancient time, it helped the sailors to sail their ship according to that particular direction with that particular speed and to reach their final destination to do the business. That's why they are known as trade winds and they are very reliable winds. Nowadays, different techniques have also come, but in ancient times, sailors used to sail their ship according to this trade wind, and that's why they named it as trade winds. Okay. Now here you can see the diagram. We have three different types of cells. One is known as Hadley cell, other is Ferrel cell, and next one is polar cell. I'll be telling you about all these different types of cell, but firstly it's Hadley cell. Hadley cell, it is found in the latitude, like they are found between the latitude of 30 degree north to 0 degree equatorial, and same for 30 degrees south to 0 degree equatorial for the southern hemisphere. Okay. So what happens here, as we all know, this is equator. Suppose this is equator and sun is just overhead of the equator. So when sun is overhead of this equator becomes warm. So the wind blowing above the surface of the equator, it also becomes warm. And as it becomes warm, it becomes lighter and it rises up. And there is one more thing, as you all know, with increase in distance, the temperature decreases. Okay, so this warm wind, when it rises up, it reaches up till the troposphere, and with increase in temperature, with increase in distance, the temperature decreases. Okay, and then it gets deflected towards the polar side. So what happens here? When it gets deflected towards the polar side, it becomes more and more cooler, denser and heavier. And due to this, at 30 degree latitude, it starts sinking over there. And if it starts sinking over there, that means high pressure belt is created over there. Okay, so it starts sinking at 30 degree north, and from 30 degree north, what happens, as I have already told you, wind blows from high pressure belt towards the low pressure belt. So wind starts moving from high pressure, subtropical high pressure belt towards the equatorial low pressure belt. Okay, because there is a gap. Suppose wind is rising up, so there is a gap created over here. So to fill that gap, the wind from the high pressure belt moves towards the low pressure belt. Okay, and this cycle continues and goes on in the Hadley cell at the latitude of 0 degree to 30 degree in the north as well as in the south. Okay, so this is known as Hadley cell because cycle is going on. It's very normal over here. Then you can see the direction of the wind in the northern hemisphere. What happens? You must have thought, when wind is coming like this at equator, then why it's not coming straight towards the equator? Why it's getting deflected towards any other direction? It's just because of one reason, that is known as Coriolis force. Coriolis force is nothing but a false force, and about this I'll be telling you later on this chapter. Okay. So what happens? When the wind blows from northern hemisphere or northern side in the direction of the wind, due to Coriolis force, it gets deflected towards the right side, and in southern hemisphere it gets deflected towards the left side due to Coriolis force. Okay, but you can also see one more thing. There is a narrow belt over here. Okay, here winds are moving like this at equator. They are not colliding with each other. Suppose the winds is coming from northern hemisphere and other wind is coming from southern hemisphere. They are coming towards each other, but instead of getting collided, they are rising up like this. They do not collide. They do not mix up at equator. It's just because there is a very narrow belt of width around 1 to 5 degree, both in the northern as well as southern hemisphere, and this narrow belt is known as doldrums. Doldrum is also known as intertropical convergence zone. Okay, so what happens, since they are moving towards each other, they come over here they are of same speed, same nature, so they do not collide with each other. Okay, they converge here and they rise up, then they flow towards the polar side at 30-degree latitude, both in north and south. They start sinking and then they start blowing from high pressure area to the low pressure area, or high pressure belt towards the low pressure belt. Okay, and there is one more thing, or one more term I told you, intertropical convergence zones. Okay, what happens here? Suppose this is equator. Sun is just overhead. When the sun is just overhead of the equator, then this is the normal situation which you are seeing on your screen. But if the sun start moving towards upward towards the Tropic of Cancer, then due to this low pressure belt created at equator region, it also starts moving upward. Okay, and when the sun comes to its regular position, this equatorial low pressure belt also comes to its regular position. Okay, and this is for intertropical convergence zones area. Okay, so now you can see here they are more consistent winds. Their direction and speed don't change much across the season. That's why they are used for trade. They flow in Hadley cell, I have told you, in both the hemispheres, that is from subtropical high pressure belt to equatorial low pressure belt between 30-degree north and 30-degree south latitudes. They flow towards the equator from northeast in northern hemisphere and from southeast in southern hemisphere because of the Coriolis force. Coriolis force deflect the wind towards right in the northern hemisphere and towards the left in the southern hemisphere. Because the trade winds are consistent and relatively smoother winds, they do not mix at the equator, as I told you earlier. They come towards the equator, they get warm, moist and rise up along a very narrow belt known as doldrums. Doldrums are formed only on ocean, not on land. This is the important topic which you can mark also. Doldrums are formed only on ocean, not on land. Doldrums, also known as intertropical convergence zones, and pressure belts depend upon the overhead sun. I have explained you each and everything, why this is moving upward along with the sun, why it's coming back to its regular position because of the sun. Okay, if sun moves upward towards the Tropic of Cancer, then equatorial low pressure belt also moves upward. The trade winds descend and remain stable at their origin, that is subtropical high pressure belt. I have told you this, that wind at 30-degree north or Hall's latitude, they start moving from 30-degree north towards 0 degree or high pressure towards